Okay, welcome again. So if you all remember, we were talking about linked list. We learned some features. We learned how to implement some functions. Today, we will be basically focusing on implementation of all of those functions. But before we start implementing, I will just do a very quick review, and then I will ask for your help and some points. Like we will need a lot of volunteers for today, so that we can rethink, reformulate the pseudocode that we planned in the last lecture, and then we will go ahead and implement them. That will be very fast, and please stop me if there is anything you don't feel comfortable. Okay, so I hope, second, I hope you can see the note screen. Can you all see the note screen?
Yes.
Yes.
Okay, perfect. I need to make some very quick adjustments, and then I will be ready. Okay, so today we will implement a class basically a template for a linked list. Let's say a linked bag that we implemented with arrays. Actually, last week we talked about implementations of many of the functions like add function, remove function. I will just quickly go over them, and just to remind you, I will review them, and then we will implement them. So just for a very quick summary, our linked list was having a lot of nodes. So normally we were storing information in variables. This time we will be storing information either in structures if you implement them in C, or we will store them in objects, which are just instances of node classes. So we made the definition of a node. So the node concept was originally, we will extend this later, but the idea of this node concept is this has two separate bins. The first bin is there to store the information, like the information you store in your variables. For example, let's say this item, this node is storing is 5, and then it stores a pointer which points to a possibly another node in the linked list. So for example, this second location, the second bin in this node points to the second node. Let's say that one is 6, and then that one, if that is the tail, like the last element in this linked list, that will be pointing to null, right? So this was the idea, and then we said we will be having a pointer. This is generally called head or head pointer, it doesn't matter. This will be pointing to the first item in your linked list, right? The idea of working with linked list was now we can extend the size of this bag as much as we want. We will just keep creating new nodes, and we will be connecting them to the appropriate locations. So that is very advantageous with respect to arrays. So unlike, again, arrays, we don't need to shift items when you are adding new items to a sorted linked list. So if you remember, in an arrays, we were shifting all the items which are greater than the target item, like new entry, so that we can open up space in that array. So this has many advantages, but also it has many disadvantages. I will try to make a comparison later, like a full comparison. But this was the whole idea. Then we talked about some functions that we can implement for specific functionalities of this class. For example, how do we add a new item? So now I just need a volunteer that we can quickly talk, so that we can formulate a pseudocode for add operation. Is there any volunteer who can turn on their camera, and we can quickly talk about the add function? Any volunteer?
Merhaba hocam, kimse yok diye şey yaptım.
Ahmet, sen misin?
Evet hocam.
Can you turn on your camera? Okay. So Ahmed, we will just try to write a pseudocode for the add function. So let me just say We will be writing this add function, and I will really need your help so that we can implement this successfully. So this is our linked list, and then we want to add, let's say our add function accepts an integer for which we will create a node, and then we will add it to the appropriate location. So let's say the input for this add function is, I don't know, an entry. So this is just an integer number. Okay, so how can I add this function to my linked list? To add this number to my linked list?
I think firstly we need any node for new entry.
Okay, so you're saying we need to create a node for the new entry. Okay, I'm
After
just
that,
writing the pseudocode, yes?
after that, we need to reach the point where we need where we add the new entry.
Okay, if you remember from the last lecture, we had two different cases.
Okay, right. Adding it head or a middle or end point and
Okay, so how do I understand if I'm trying to add this as the first node, like the head pointer, or if it's just an interim or the last node? How can I understand this? So this is the number I have. I have
Okay.
this in entry.
as I remember, sir, we keep a variable as a counter, right? Or yeah, we have a variable item count, for example.
Okay.
We can check it. It is 0 or not 0.
No. What I was meaning, what I meant is, so this is the entry. So we have a number here, and this is a sorted linked list.
Right.
How do I understand if that entry will be the head node, like the first node, or it will be just an interim node? Can I make a very quick comparison and say, okay, like this will be the end node? So I want to write an if condition here. So let's say if an entry is the first node, let's say is going to be the first node. So that will be a special case. And then else, if it's not the first node, we will do something else.
Okay. For if head next is null.
No. Let's say there are multiple items, like we have 2 items here. And then we had a new entry. Let's say its number is 3.
Okay.
And then we created the node, which includes 3. So how can I understand if that is going to be the first node or it's just going to be an interim node?
We can check the first node. If it is smaller than the first node,
exactly,
it will be first node.
So so this if condition, we will check this by comparing if an entry is smaller than the item in head pointer or the item in first node, let's say first node. So this is pointed by the head pointer for now. So this is the if condition we have. So this is how we are going to check if we are adding as the first node or if it's just an interim node. So if it's the first node, what do we do?
We need a current node to keep some node there. We will create or
okay. So let me just
now we can reach 5 node. We can reach the 5 node with head node.
Yes. So let me just do this. So this is new node, and I am trying to add this as the first node. So what modifications I should do?
We also need another node to keep to keep five node information pointer.
Okay,
Uh,
so, okay, how do I do this?
We will create a new node as a name, current node, for example.
Okay,
Or
so you mean we will create a pointer as current?
yeah, yeah.
Okay,
Uh,
and
okay. After that, now we can make operations like we will cut the heads pointer from 5. We will edit to new node. We will show now from head node to new node.
this one,
Right.
so we will say head is now new node. So head is now pointing to new node, and then what else?
After that, we have the information from current node. We know which is next node. So new mode, new mode, new mode next is current next. Current, just current, right?
Okay, so we will make this connection. So instead of pointing to null, now this will point to this. Then we will just, I will just add something. We will just increase item count so that we can keep track of the number of items we are having in this linked list. Okay, thank you very much, Ahmed. So I will maybe we will get another volunteer for the second part where we are trying to add as an interim node. So in this case, let's say I have 3, I have 5, I have 6, and then this is pointing to null. And then let's say I am going to add number 7 here. So this is 8, I changed it. Okay, so any volunteer when we are trying to add to an interim node?
I can do it.
Of course, IPEC. Okay, so what should we do now?
First, we need two pointers that are previous and current.
Okay, so we will create a current pointer and then a previous pointer. So where they are going to be pointing?
Previous will be null and current will pointing the first node at the beginning.
Okay, so initially, oops, sorry. Initially, current will be pointing to head and then previous will be pointing to null. Okay.
Then we will traverse the list to find where we add 7.
Okay, so what is the condition for traversing the list?
We will compare our new entry or an entry with the current node.
We'll compare,
So if an entry is smaller than current, we will go one more.
No,
like
if current is smaller than an entry, you should go further, right?
Yes.
Okay, so what is the condition that you will be stopped? So you said if current is, let's say just move the pointers until current is greater than an entry, right?
Yes.
Is this okay? So we start from here. So this is current, and then previous is currently null. So previous is currently null. So 3 is less than 7. We will just move the pointer so that current will come here and then previous will come here, right?
Yes.
And then since 5 is less than 7, again, we will move them one more time. And then 8 is not less than 7, then we will stop.
Yes, then previous is next will be new node.
Okay, so, oops. So at this point, we will set previous is next to be new node. So this connection will be changing, okay? And then?
Then new nodes next will be current.
new nodes. Next will be current node. So that will be now pointing to this. And then what?
Then we can destroy current and previous
Yes,
pointers.
it really doesn't matter for now because each time you call this, it will be automatically refreshed. But especially for delete operations, I will ask you to remove those pointers and nodes, clear them. But don't really try to clean the pointers themselves. It's not really that important. But thank you. So there are some questions I need to ask you here. First of all, so you said we will stop until current is greater than an entry, right?
Yes.
So what if, let's see, oops. So I will change the numbers a little bit. So in this case, current will be never greater than an entry.
We can change the condition like current. If current is smaller than, we can go one more.
Okay, so like, for example, we came here. And then if based on this condition, current is still less than new node. So I need to go one more time, right?
Yes.
So if I go one more time, now this will be pointing to null.
Yes.
And then I can't do this check again because there is no item in the null pointer. So there's no node where what current is pointing. So that will definitely give us a runtime error.
We can add another condition to check if the next is null.
Perfect.
If
so
that's the case, that's the last node, and we should add it to end.
perfect. So add another condition to check if we reached the end, right?
Mhm.
So that's great because those small details are important because it's like you will not get a compile time error like during compilation. So you can only notice this while you're running the program. So that will be a problem. So you will be running things and then suddenly it will stop somewhere and it will be difficult to understand. So we add that condition, and then there is one more special case that I want to discuss. So here we talked about adding to as the first node, and then we talked about adding as an interim node or the last node. So that was the same case, but there is also one more special case that we didn't talk when head is null. So when the list is empty, so that is a special case. So now we can't do any of these things. We don't have any current, we don't have any node in the system. So in this case, we will just create a new node and this head will just point to that node. Can you all understand this? Is it clear? So if this list is completely empty, then we won't be having any nodes to deal with any of these pointers, but we will be just creating the node, and then we will be connecting the head directly to that node. So that is one more special case, and this was the head function we talked. So let's start implementation. We will test add function, and then we will continue. With the remove function and the other functions. Thank you, Ipek, by the way. We'll start this screen share. Is it all clear for everyone? I hope this remind you the basics, like the fundamental parts for this linked list operations. So now I need to share my code screen so that we can continue. We need to implement a lot of functions here, so that will be a little bit time consuming, so let me show you. Last time we worked on this node class, if you remember. So this was the idea. So we use again class definition so that we can hide the information in this nodes from from errors, the possible programming errors. So instead, we define some interface functions for the linked list so that it can, like, for example, if you're trying to set the item, you will call the set item function. If you're trying to set next, so change the next pointer, you will be calling this function. If you're trying to get the item or get next pointer, you will be calling these functions. So these are implemented here. I think we implemented them together, as I remember from the last lecture. Sorry. Okay. And then I think I showed you this. I'm not sure if I showed you this, but we have this H file for our linked list. So in this case, it's a link back. So let's just review it very quickly to see what we should implement. So it has a private part where it stores the head pointer. So head pointer is the most important pointer in this linked list. So if I have an access to head, I can change anything. The nice thing here is that head pointer is a private variable here. So no one besides like this implementer of this function can access the head pointer. So they can't do anything without our knowledge. And then we have another private variable called item count. So we have a function, private function, get pointer to. So this can return you a pointer for any target item you want. And so that is also a private function. And then we have some public functions. So so let's just try to review them. So we have this constructor. If you remember, this constructor is the initialization. So whenever we create an instance of this function, we will automatically call this constructor where we should initialize these two parameters. We will write them. And then we have this something called a distractor. This is a virtual function. I will try to explain what this is going to do, but for now, I will just skip it. So we won't, let's say we will not be using this for now, but the whole idea here is that whenever you want to delete this linked list, it should, so we said we are creating a lot of variables in the memory. We should return them back to the memory. So these distractors are generally there to make sure that you clean all those variables, all those nodes. You return all those spaces back to memory. So this is how a distractor works. But the issue is you should implement the distractor in most cases, especially when you're doing this dynamic memory allocation. You're dynamically creating new places, new objects in your memory in random locations. And you are the only one who knows the relationship, like the pointer relationship between those spaces, so that you should start from the head node and start like cleaning all those items one by one, right? So you will be cleaning them all one by one until you reach the end, so that you make sure that you return all those spaces, all those occupied spaces back to the memory. So we have a function for get current size, which will basically return this item count. We have function for is empty to check if the list is empty or not. We have an add function and remove function by using which you can add or remove entries from your linked list. We have the clear function, which can just clear out all those nodes. This is basically the implementation for the distractor. So in the distractor, we will just call clear and it will clear everything. Contains function is to check if a specific item is in the linked list or not. And then we can check the frequency of an item. So how many times an item occurs, how many times an item occurs in your linked list. And then the last thing is just print back. So it will be just printing the entire list. Is this clear for everyone? Like this is just the function prototypes, like it's an H file that we will be giving to other people. So by using this function list and this input-output relationship, they can understand how they are going to be interfacing with our linked list without knowing the implementation detail, right? Okay, so let's go to the CPP file where we have just all of those functions which are empty for now. So we need to implement them, but for now I will be removing some of these, just commenting out so that we can make sure that we can work with those. So let me just go here. I will be commenting out some of them because I don't want to implement everything all together. We will be testing them one by one. We don't need this for now. So let's say we will implement this very basic functions. Current size is empty, add, and then we will be testing print back. So we will just add new items and print the back just to see if we are adding successfully. And then we will start implementing those other functions. So I will be only having constructor, get current size is empty, add and print back. So let's just go here, add. So we will be commenting these out. And I need some volunteers for implementation, so please be ready for helping me during these implementations. No, sorry, this is something we were going to implement. We need this print back. We don't need this get frequency for now. We don't need this contains for now. Anything else? And then we don't need this get pointer to for now. So instead of implementing the whole thing and testing, which is generally a bad programming practice, we will be implementing some parts, do our tests. If they're successful, we will keep adding more functionalities to our class. Okay, so I need some volunteers very fast for this implementation states. And that would be great if different people start talking. Or I can pick some volunteers.
Ben yapabilir miyim hocam?
Tabii ki, can you also say your name and turn on your camera?
Muhammed Erkam.
Okay, perfect. So Mohammed Erkam. So let's, is there anyone that, like, let's start with the constructor. So we will go one by one. So we will implement this constructor function, right? So, and the whole purpose of this construction function is the initialization process. So if you remember here, we have two private items that we need to be dealing with. So we need to initialize them here so that we can create an instance of this object. So we will be initializing this head pointer, and then we will be initializing this item count. So what should I write here for this constructor?
Hocam açıkçası ben alttaki fonksiyonu yaparız diye düşünmüştüm ama o
Okay,
kısmı
which one?
yani herhalde siz yani fonksiyondan başlarsınız diye düşünerek aslında yapayım
No,
dedim.
I mean, which
Kısmı yapmaya çalışabilirim.
Okay, which function do you want to implement? You mean get current size is empty, add function, print back. Which one did you want to implement?
Aslında direkt isempty yapmak için yapmıştım ama.
Okay, but we can do isempty, but let's also do the constructor with you, and then we will do isempty together, so that it will be meaningful. Without doing the constructor, isempty really won't be that meaningful. So I can help you for the constructor. So the idea is we have a head pointer, and initially we need to put some initialization value into this head pointer. So we create this linked list.
Yes.
So what should we initialize the head pointer with?
İlk elemanın adresi, address of first element.
Yes, but there is no item. It's completely empty. We just created this object.
Head pointer is null.
Perfect. So that is really that easy. So we will say head pointer is null pointer. Oops. There's a language issue. Oops. Which I can't understand. Somehow my keyboard language swapped. Okay. So head pointer is null pointer. That is perfect. So this will create an empty linked list for us where head pointer is pointing to the null pointer. And
Yes.
then we have something called item count. So how do we set the item count? How do we initialize it?
That is 0 because we have no
Yes, so item count
I'm not-
initialized to 0, right? So
Yes.
now if you look back to our age function, we had two private variables, and here in constructor we initialize them to some specific information so that we now have a working, we can now have a working, fully working linked list. Okay, let's also do the isEmpty function together. So
Yes.
what should we implement in this isEmpty function?
Let's make a Boolean variable.
Okay. What is the name of that variable is going to be?
It can be empty.
Okay.
And if empty is
No, empty is uninitialized for now. You can say if empty is not initialized yet. You just created the variable.
if head pointer is null pointer, empty is false can be
Okay. So you're saying
true.
if head pointer is null pointer, which is initially null pointer, that was the way. Okay. So what do we say now?
Empty is true.
Empty is true. Perfect. And then
Return empty, we can say.
but let me do this, but there's a problem.
In the if statement.
Oh, okay. Okay, so we need this then.
After that, return true, we can say.
Return true. Why? So you're trying to check if head pointer is null pointer. If it is, then you return true basically. But if it's not null pointer, are you still going to turn true?
Sorry, false.
Yeah, exactly. So in this, so it's like if head pointer is null pointer, which means that this list is empty, we will return true. Otherwise, we will return false, right? And we didn't even
Yes.
need to write an else statement because it's by default, it's an else state. Okay, thank you very much. But I will make one quick change here just for you to get a very good programming practice. So so the only thing we are trying to do here is to check if head pointer is null pointer. But actually, we can, instead of that, we can also check if item count is 0. That is the same thing. Like they will both tell us if that is empty or not. So what I'm going to do is, instead of all these 6 lines, I think, this lines of code, I will be doing one line which will be equivalent to all of these. It's the same thing basically. Return head pointer equals to null pointer. So I can even do this. So this thing by default, so this is a comparison. If it compares if head pointer is equal to null pointer. If they are, this will be automatically giving us a Boolean variable, either true or false, which will be directly returned by me to the calling function, right? So this is completely correct. There is no issue, but the only thing that we need to fix is to reduce memory usage instead of like creating a new variable, or instead of making a like additional if else key comparison. We will just write a single line of code and then we will be returning. But there is nothing problematic with this lines of code. It will work completely fine as this single line will do. There is no problem. Okay, another volunteer for this get size function.
I'm a volunteer.
Can you? Okay, Sezgin.
Yes.
Okay, so how do I get the current size?
Current equals to head pointer.
What?
We should add another pointer as current.
No, you mean, I mean get current size is the number of items in the linked list.
Yes, to count this, we should another pointer.
Okay,
No?
but there is something I should remind you. There is a variable called item count, which keeps track of the number of items. So you don't need to count each time, because each time we add or remove something, we update this variable. Do you understand?
Can you repeat this again,
Yes.
please?
Like, there is a variable called item count, which keeps track of the number of items in this list. So you don't
Yes.
need to count again. We have that information already.
Okay. Okay. We don't count.
Yeah.
Okay. Then return item count only.
Yes, exactly. That it's really that simple. Just you should just look at this and just implement it. That will be perfect. And then can we do? Sezgin disappeared. Okay.
Okay.
let's,
Okay.
Can
I
you
am back.
also do the print back function for us? Then I think that will be very similar to what you were trying to do. So instead of summing, now you will be printing.
We are going to print all all elements in the list. Okay.
Yes, exactly. So you were planning to count them. Now instead of counting them, just print them.
We should display the item count. Okay.
What?
Do we display item count or
No, we will print all
items
the
in the
items.
list? Okay. In this time, we should another pointer. Then
Okay. So I created, let's say, another pointer called node pointer, maybe a current. Okay, where this is
Yes.
going to point.
points out to head pointer.
Okay, so this will be starting from the head pointer. Then what?
While current is not equal to null pointer.
Okay, why are you checking, making this condition like this check?
Because this list may be empty or we are in last item in the list.
Okay, like what I mean is, I think you are planning to traverse the list one by one, and you are trying to check if you reach the last item, right?
Yes.
Okay, so just trying to make sure that everything is also clear for your friends. Okay, so
Okay.
what do we do then?
See out.
Okay, I will just say std cout. I don't know if I implemented them correctly. So std cout, like cout of the
Yes.
std library. Okay.
Current. The current data.
Current data. So I will remind you something. We have some functions to reach current data, like an item in the node. So we have this get item function. So we should call that function here with this pointer. So I will say current get item, right?
Yes.
And then I can
And-
just add an end
Yes.
line so that we
Yes.
go to next line. Okay, and then what?
Then yes, that's
What?
that's it.
That's it?
It
Okay.
it prints out every item in the list.
No, this will print the first item in the list until infinity.
Yeah, sorry. Yes, current. After that, current equals to current next.
So again, in order to reach current next, I will be calling get next function.
Yes.
Right? Thank you very much, Sezgin. So is this clear for everyone? So what Sezgin implemented was a very efficient and nice code. So so we created a new pointer current, which starts from head, and then we started traversing the list until we reached the null pointer, which is basically the end of the list. And then for each, like during this traversal, for each node, we accessed the item of that node, printed it, and then we move the pointer. So this current equals current get next will move our pointer to the right. So that was very nice. And then now we need to implement this add function, which will include some details, but we will be doing this this carefully. I need to do this. I have a battery problem, power issue. Okay, I hope we don't have a problem. Okay, before the break, let's implement this add function and test it quickly, then we will be giving a break. But I need a volunteer, like someone will go into details and crack this add function for us.
Yeah, I do.
Where are you?
Murat.
I can't really see or hear your, okay, Murat. Murat?
Yes.
Okay, so with Murat, we will be implementing this add function, and I will try to guide you as much as I can to make it systematic, but of course you're free in your decisions. So we will be adding this new entry here. And if you remember, Murat, there was something I said, like the last case, that is a very important special case. Do you remember that case?
Yes.
We will be adding that item. So the idea here is we started with an empty list. So the first thing, whenever you call an add function, the first thing will run, the first time it runs will be running that special case when there is no item in the list, right? So how do we control that check that condition?
Item count equal to 0. We have
Perfect.
to check.
So what I will do is, let's do an if else statement. If item count is equal to 0,
0, then
which means that there is no item
no.
in this list. So what I should do now?
Then head pointer should point our new entry.
But new entry is just a number. It's not a node.
Then we should create another node for new entry. Okay.
Perfect.
It's integer.
Perfect. So I will just say new node, new entry, right?
Yes.
So what did we do here is we checked if there is no item in the list. So basically list is empty. So we just create a new node on the head pointer. That's all. One alternative can be is creating a new node with a different pointer and then setting head pointer to that node. But this is basically the same thing, right? There is no difference. Okay, so now let's say the link is not empty. So what should we do now? Our list is not empty.
Yeah. Then we have to traverse linked list.
Okay, but again, in that point, we had another special case. Like if there are multiple items, but if you are adding as the first node versus if you are adding as an interim node, those were two different cases, right?
Yes. Okay, then if we have one node, then
no, it's not about having one node or n node. Let's say we have 100 nodes, but the new item you are trying to add will be the first item. This is a sorted linked list.
Okay, sorted. Okay, then head pointer should point our.
No, how do we, first of all, we need to make that conditional check. So we need to, again, separate this else statement into two conditions where if we are adding as the first node or if we are adding as an interim node.
Then we should check item count again, right?
No, it's not about item count. Like imagine you have 3 nodes.
Yes.
They are 5, 6, 7. And then the new entry I'm trying to add is 2. Which means that new entry will be the first node. But how do I make that decision?
Less than, we have to check, compare their values.
Perfect.
Right.
So whose values? So we will make a check here. But what is that condition? Like I like one of your friends when we were doing this implementation, they told us. I don't remember who was her. I think um, maybe Pek. I don't really remember, but
If
they
new
told us what?
if new entry less than our first node's value,
Okay, so how do I access the value in the first node?
head pointer points it, but we can assign another current pointer to it because we should.
It doesn't matter. We can check
Okay.
from
Head pointer get item. I don't remember that function. Yes,
Perfect.
get item.
So if the new entry is less than the
Then
item in
get-
the head pointer, which means that you are adding this new node as a head pointer. But the problem is we didn't even create the new node. Let's just, I will make it trickier. I
Yes.
will help you. So I will be creating that new node here very fast. New node to be added, let's say. Then new node with this new entry, right?
New entry.
So this is just to create that node. So now you know that you will be adding this as the first item in your linked list. So how do we make this pointer connections? I think your friend, maybe Peg, explained this. So what do we do in this step?
If this condition is true, then node to be added next.
Wait a second, node to be added. So we will do set next, right? Because
Yes.
we can't directly access
Okay.
its next.
Okay. Set next.
Give me a second. There's a
Head pointer. Set.
okay, so we are setting the next of this node to be added as the head pointer. Okay, then
Yes. We have to update head pointer now.
okay, so what will it going to be?
That is new entry. New node to be added.
Perfect.
Yes.
So this is very nice. So now we did these two special cases. If the list is empty, we created the node as the head pointer. If it's not empty, we created that node and we checked if it's going to be the first node. If it's first node, we did the correction. We did the manipulation. So
Okay.
now what if it's not the first node? So your friend said we need to initialize 2 pointers and then we will move them. So we need to implement all of those things.
Yes. Then let's initialize two nodes.
Okay, so
Temporary
pointers.
node previous. Let's call previous.
Perfect. So previous, what was the initial value for the previous? Do you remember?
Null.
Null pointer. Okay. And then what else?
Then current pointer. Let's
Node pointer current. So what is the initial value?
same as head pointer.
Head pointer.
Head pointer.
Perfect.
Yes.
So now we have these 2 pointers, and then we said we will do something. Like we will try to we will do some checks. So I think she defined a loop so that we find the location for this new node that we are going to add. So how do we do this check, and how do we find its location?
Should we? I think we should use for loop or any other loop to traverse linked list.
Which do you want, for loop?
Yes, for loop.
Okay. So
For actually, we can assign current pointer inside for loop, right? Current from start.
yes. So you mean
Yes. Just declare it, but not
okay.
assign head
Just
pointer.
declare it, and then I will say current starts from head pointer. Okay.
Yes.
Then what?
Our condition current until null, one condition at least.
Current is not null?
Not null, yes, not equal to null. And we need another, no. Okay, then current is assigned current next, right? Yes,
Yes, so I just say get next.
get next.
Okay, so
this
this thing will start moving. Let me do this. I hope you can see the entire screen, still see the entire screen. But so what this loop is doing is it will start from the head pointer. It will check. It will so until it reaches the null pointer, it will keep going. Okay. So okay, let's do the rest, and then we will talk about some possible issues we may have.
I want to use our first check, like if new entry less than head same.
What?
Our list would be sorted. Then if new entry,
Here?
yes,
Okay.
less than pointers entry.
You mean
Current.
gates?
Get item.
Okay.
O zaman then we insert there, right? Our condition. We traverse whole list and we check new entry less than current items less item.
Okay. So
If it is true, then we should update previous current.
yes. So if your new entry becomes smaller than this item, then you should add it here. But
Yes.
there's a problem. You need to make a lot of conditional checks. First of all, whatever you do it, unless you use additional breaks and returns, this is a for loop. This will go all the way until it reaches the end. And the issue is, whenever you reach the first item, which is smaller than like this new entry, like when this new entry becomes smaller than the current item, this condition will be valid for all the rest of the items. So like imagine you have a list of 1, 3, 4, 5, and then you are trying to add 2. So new entry 2 is less than 3, but 2 is also less than 4 and 5. So this will be repeating itself. So you will be keeping that same node everywhere.
I thought we would use return, but no need.
Okay, perfect. So you mean you will break this loop at some point?
Yes.
Perfect.
Yes.
Okay, let's do this then.
We don't need to traverse whole linked list if you find the correct item,
Okay.
correct place. I
Okay.
thought that way, but
Okay.
the
There
choice
is no
is
problem. No. So what do we do here? And then what do we do? I don't know if we need this else, but let's just remove it for now. So we were traversing the list, and then at some point we said, okay, this is the location, right?
yes.
And then what?
But we forgot previous pointer. We should assign something to it. Where?
Can I suggest you something?
Yes.
Instead of doing a for loop, let's do a while loop. Because we have conditional checks where you will notice that you need to stop, and then at that stopping point you can add your pointer. Because so for example here we are traversing the list, like we are traversing the list for current, but at the same time previous should also traverse the list. Like it should follow what the current is doing.
Yes.
Of course, you can also integrate them all here to for loop, but this is against the nature of for loop. For loop is meant to run to traverse the entire list, but your goal is not to traverse the entire list. Your goal is to traverse the list until you reach some specific conditions.
That place where we assign previous node.
Yes.
Therefore, okay.
So can I change this to a while loop very fast?
Of course. Of
Okay.
course.
So just to make sure that we use the nature of this statements like this, by definition, for loop is like meant to traverse the entire list, but while loop is meant to traverse until reach a specific condition, right?
Is there any syntax that we can use comma and update?
Here,
Yes, previous.
yes, you can. You can also implement them here inside the for loop. So, but you need to understand how the for loop works. Like for loop starts initialization, right?
Yes,
And
then checks condition
checks
at the end.
condition, runs the content, then makes this update.
Yes.
Right. So you need, if you know the order of the for loop, then you can do all of those things very easily. There is no issue in that.
Yes, for while same identical things, but prefer choice.
Yeah, exactly.
Okay, while then.
So I will just clean this.
Okay.
Okay, for now. So we are implementing a while loop, and remember our conditions. The thing you're looking for is to make sure that the item, like the new entry, becomes smaller than the item in the current node, right?
Yes.
But if you remember what I told, I think Ipek when she was doing this, there was another condition. What happens if all the items in the list is smaller than your new entry? Basically, you will be adding as the last node. So in that
Current
case, we need to make one more check.
Current is not equal to null.
Okay, so let's do this. While
if we reach end of the list, then
okay,
according
so
to our code, yes, let's initialize head pointer now.
Yeah. So you're saying while current is not equal to null pointer.
Yes.
Okay, and we have one more condition.
Then we should compare values.
Oops, we should compare values. Oops.
Co-
There is an issue. Okay, we will say, for example, currents get item.
Yes.
Not here. Currents get item while this is less than new entry, right? So if our item is still less than the new entry, we should keep working. We should keep going. And then while current is not null pointer, we should still keep moving forward, right?
Yes.
So what do we mean by move forward? So we need to update both of these pointers. So
pointers.
Okay, how do we update them?
Previous points our current node, and current points current next, get next.
Perfect.
Yes.
So this will go until somewhere. So let's check the end conditions. Either we reach an item which is larger than new entry. So this is where we will be adding between those two nodes, or the other condition is the current became the null pointer, and then previous is the last pointer in that case, right? So now in this case, here you should be doing the addition between current and previous. So this is our node. We will be adding it between previous and current.
Okay. Then previous should point our new node to be added.
Okay, so this will be pointing to node to be added, and okay.
Then node to be added get next should
Set
point.
next, you mean?
Yes, set. Yes, we use methods.
Okay.
Set next, that should be current.
Right?
Yes.
Perfect. So let me check if there is any problem. So we are adding, so we added this thing here. Otherwise, we will add here, or otherwise we will add to an interim or the last node. And then this is the end of all statements. Then there is one thing we need to add right here. So we added something, we need to update a parameter.
Item count, of course.
Exactly. So we
Item
will,
count increment.
we will increment the item count. And then since it's a Boolean variable, I will just say return true. So in arrays, we have this problem of checking if we can add or not. But in linked list, we don't really have this problem. We can add as many as we want. But just to be consistent with array-based implementations, I will just adding that Boolean and true function. Like normally this is void. Like this is, we don't even need to return anything because we know we are going to add this anyways. But the idea is the other side of the program should not know if we are doing an array-based implementation or a link-based implementation. So if I change this, they will still be getting a true or false. They won't even notice what type of implementation we used, right? It's just, again, a precaution. Thank you very much, Murat. I will quickly review this. So this is the add function. We will first check if item count is 0. So in that case, when the list is empty, so we created the node and attached it as the head pointer. If it's not empty, then we have two conditions. If we are adding as the first node or if we are adding as an interim node. If we are adding as the first node, that was very easy. We created the node, and then if it's the first node, we just set the next of new pointer to head pointer, and then we update the head pointer. If it's not the first node, then we initialize these two auxiliary pointers, which are previous and current. We move them, like we traverse them in the list until we reach one of these conditions. Either we reach the end, or either we found its location in the interim node. So we are just updating the locations of the pointer, right? And then when we find its location, we just updated the pointers again, like the previous and by using previous and current. Then we just incremented the item count and we return true. So that was very nice. I hope this will work perfectly fine. Is there any other thing that we didn't do for now? Okay.
Hocam,
yes.
bir şey sorabilir miyim?
Of course.
Orada en baştaki mesela 0 değilse diye bir yazdık ya bir yere.
This one.
Evet, 0 değilse else'de mesela direkt en baştaki en başa eklemek için new entry'yi bir kod yazdık ama onun yerine direkt şu en alttaki while'ı kullansak yine yapamaz mıyız? Alttaki while'la.
You mean this? Which one?
Evet hocam. Yani şu yukarıdaki if else condition'da dedik ya hani 0 değilse item count'umuz 0 değilse
okay, this one.
bu aynen en başa eklemek için bir kod yazdık oraya.
Yes, yes.
Onun yerine direkt while'ı çalıştıramaz mıyız aşağıda en son yazdığımız while'ı?
So you think this is not a special case, like this can cover both conditions?
Aynen öyle düşündüm bir.
Yes, actually it is, but there is one thing very important, one key difference. If you're adding something as the first node, then you should update the head pointer. In this part, head pointer will be still pointing to the initial node it had before. Like if you check this codes here, nothing changed the head pointer. And it shouldn't. But if you're adding something as the first node, then you should update the location of the head pointer because that new node now will become the head node.
Anladım hocam.
Right? So that is the only difference. Besides that, I completely agree. And actually, there's a concept called dummy head node, which removes that special case as well. But we won't talk about that one in this course a lot. Okay.
Tamam hocam, sağ olun.
Thank you. So I will resume again. Can I see all of you very fast? just for a quick talk. Okay, perfect. That is really great. At least I'm seeing people again for more than an hour. Is it going well? Like, do you understand how we do this implementations? Like, do you like the way we implement these things? Or is there anything you want to change? Aslı şöyle yapayım. Give me a sec. Okay. Resume. If you want, you can turn off your cameras. That's completely okay. So let's open this code screen again. So let's remember what we have done. We implemented constructor so that we can initialize, we can get size, we can check if it's empty, we can add something, and we can print something. I think we implemented all of these functions, right? Let me see. Yes. Okay, is there anything important that I forgot? Check. I think they are all okay. Now I want to test this main function. I want to write a main function and test this, especially the add function, to see if everything is going well. So I already added link back here included. Will have IO stream so that we can print something. Okay, so now we have this class for linked back. We should just create an instance of it and we should test it. So let's just, again, I will work with pointers. So let's say I will create something called myback. I can do this with pointers. That will be easier for me again. And then I will say new linked back, right? So now this line will create a new object, a new instance of this linked back class. And then whenever you call this new linked back function, which basically calls the constructor. So if you go ahead and remember what we did in the constructor, we just initialize this as an empty linked list where our null pointer head pointer points to null pointer, and then we have item count 0, right? So this is how we initialize this. Actually, we can now say maybe just to check, we can just say std maybe cout the number of items. Let's say the number of items is how do I access the number of items? So we can just go ahead and look at this h file. So we can get the get current size. We can call get current size function so that we can print the number of items. So I will just say myback. Oops. myback get current size, right? So this should print the number of items, and it should be 0, hopefully. Yes, so the number of items is currently 0, so that is nice. So let's add some items. myback. So how do I add new items? I will call the add function, and then I should give a number. For example, any number. Let's say we will give 5. So we will add this, and then whenever we add this, I will again print the number of items again. And actually, I can even call the display function, right? What was print back function, so that I can get the whole list of the items in this list. So since we are adding to a completely empty linked list, so this will be our first special case here in the add function, right? This will be this special case. This should be, and we will test this. Okay, let's run this. Okay, so this is perfect. So now the second time when I call this after the add function, it says number of items is 1 here because we added only 1 item. And then when I say print back, it printed 5. So let's test different scenarios now. So I will just say std cout adding more items, just to separate this part from the other parts, right? Okay, let's add myback add what number you want to add. So we need to be testing all the special cases. So let's say I will be adding 8, and then I will just display the content again. So it should be 5 and 8. That is perfect. And then let's add another number. So by adding 8, we added to the last. So let's add an interim node. So we can say add 7. So now it should be 5, 7, and 8, right? So this should be added as an interim node between 5 and 7. Okay, now we have 5, 7, and 8. So this is very nice. We are adding items in a sorted order. That's perfect. And then let's add something to the beginning just to test if we can add as the first node in this list. So now this should be 2, 5, 7, and 8 in the sorted order, hopefully. Perfect. So I think we tested all conditions we have. Do you want to test anything else here? So we can also print the number of items.
I want to test same item, for example, 7 again.
Perfect. We did not take any precaution for adding same item. So, but you can quickly understand what will happen. Like if you look at your add function, adding a duplicated item will, what it will do is you will just make this comparison because this one goes until you reach something bigger than this. So basically it will be just added next to that duplicate item. So let's test this. So let's add maybe, which one you want to add as a duplicate item?
7.
7? Okay, so let's add it here. Two, 5, 7, 7, and 8, right?
Yes.
Any other thing you want to test? Everyone. Okay. Is there anything we would like to test here? Basically, we tested print back, we tested add, we tested get current size, we tested link back. We can also test is empty. That will be very easy. So, which is really doesn't even work to test, but we can say if my bag is empty, we can just say std cout the bag is empty, right? Right? Else the bag is not empty. Maybe I can just add this, and I can also test this right here at the end. So initially it should say it's empty. So it starts with the bag is empty. And then when we add more items, now at the end it says the bag is not empty. So empty is also working perfectly fine. Is this all clear for everyone? Do you have any suggestions, any issues for this? Anything you don't understand? Because if we are good with these functions, we will be working with the other functions. Okay, so let's work with the other functions. I will just try to remember. Okay, so we have them all here. So let's just look at these functions first. So what we will be implementing? We will be implementing a remove function which will remove a specific entry. We will be implementing a clear function which will remove everything. So we can just say this will be dependent on this function, maybe. We will be implementing a contains function. So that contains function will check if we need that, if we have that entry in our list. So that should be easy. This doesn't depend on anything. We have a get frequency of function which will count the number of times that an item occurs in our list. So that is also a standalone function which is very easy. We have this get pointer to function where we will return a pointer. So this might be useful for our remove function, because whenever we want to remove something, we can immediately get a pointer to that target item. So these will be dependent. So let's start with some of these functions. So I will open all of these so that we can implement in the other side. Okay, oops, not this one, CPP. Okay, so I will try to implement some of those one by one. So let's look at this these functions. So check something very fast. Okay, so I don't know what is the best way to implement those, but let's implement this get frequency of function. So that will be a very simple function for us. We will basically count the number of times an item that an entry occurs in our list. So so the idea here is so in order to count the number of times, we should traverse the entire list until we reach the end. So we can't stop anywhere in the list, right? So we need to check all the items one by one, right? There shouldn't be any problem in this. And then we need a variable to store the frequency. So let's say that will be starting from 0. So I can since I'm going to traverse all the items anyways, I can just write a for statement. So for initialization, I will be using a pointer as current. So the idea is now, let's do this current. So I will be creating a pointer called current, which will start from head pointer, and it will go all the way until we reach null pointer at the end. And then when I am traversing this list, I will check if the item in the current node pointed by the current pointer is equal to an entry or not. If it's equal, then I will increment my frequency, right? So let's do this. So in the initialization, we will say current will start from head pointer, right? And then the condition is current is not equal to null pointer. And then our increments is current, we will just move current forward. So current will be current's next. So this is very similar to what Murat was trying to do in the add function. So we start current from the head pointer, and then until we reach null, we move it one by one. And then for each of those moves, what I'm going to do is I will check if an entry is equal to current get item, right? So I'm checking if the entry is equal to item in the current node. If it is, then I will be increasing my frequency, right? Is this all? Is there? Can you all follow this? Is there any questions you have? Yeah. There is something we missed, but is there anything else, or is there? Can you catch that thing we missed here?
We should return the frequency.
Perfect. At the end, we should return the frequency. Definitely. Is there any other problems you see here? So, for example, does it work if it's completely null? Like if the list is completely empty, what is the result is going to be?
Zero.
Yeah, so we don't foresee any problem. So if that entry is not in the list, is there any problem? So we will just traverse the list, there won't be a problem. So do you see any issues, any possible problems here? Okay, actually we can test this. Let's open these one by one instead of opening all of those. We made a mistake here. So we didn't have remove, we didn't have this, we didn't have this. So we just implemented this frequency of, we can just go ahead and check this. So here, for example, we have 2 of 7, right? I don't really want to do this is empty again. This is very long and confusing, but it's okay for now. So I can just say std cout so the frequency of 7 is, I can say my bag. We can just test this very easily. What was it? Get frequency of 7, right? So I'm just trying to print the number of times 7 occurs in this list. And I hope it will work perfectly fine. And it will say 2. Yes, the frequency of 7 is 2. So let's test another number. Let's test 8, which should be only 1. Okay, there is a problem.
Hocam
Hocam,
yalnız 7'yi düzeltmediniz. Get
Okay.
frequency of
I am
7
very happy. I am happy that we didn't make any mistake in the get frequency of, but I'm not happy because I couldn't show you an issue so that we can debug and solve. Okay. Okay, so that is one. So let's test a number which doesn't exist here. Let's say 80. Okay. Okay, I think everything works perfectly fine without any issues. Unfortunately, we write very good code together, so we can catch those problems. Okay, so what else? Which one should we continue? Can we write this get pointer to function? Because this is very similar to get frequency of. So let's write this get pointer to, which will be difficult to test without implementing the others, but at least we can implement this very fast. Get pointer to. This is so the purpose here is that we will return the pointer. We will return a pointer which points to that entry. So this will be very much like, let's say, we don't need frequency part, but it will be very much like this. Actually, it won't be, so this won't need a while loop because we won't be going until the for loop. We won't be going until the end. We will stop whenever we reach that item or we reach the end. So we need to make a decision here. So what we are going to return if that entry does not exist in the list. Okay, I think it's already here. Returns either a pointer to the node containing a given entry or null pointer if the entry is not in the bag. Perfect. So if we reach the end, then we will be returning a null pointer. If we found it, then we will be returning a pointer to that item. So how do we start? So let's say what I am trying to think what we can start with best. So I will start with the head node pointer current is head pointer. I think a while loop here will be better. So I will write a while loop so that we can include both of those statements. So first stopping condition is current is null. So we will only continue if current is not equal to null pointer, right? So that is the first condition, right? So if current is null pointer, we should stop and return that null pointer because which means that we are done. Like we reach the end, either an empty list or we reach the end, then we will be returning null pointer because we couldn't find that entry, or we found that entry. So that is the thing we need to check here. We found that entry, and entry is not equal to current item, I hope. Right? Do you think this is logical? Otherwise, I will just move current. Get next. And then what I am thinking is just to return the current here. Okay, we should validate this. Can you all help me? Can you check if you see any issue here? So we initialize a pointer called current, which starts from head pointer. Then,
Hocam bir şey sorabilir miyim?
of course,
Mesela diyelim 2 tane 7 var. Bu ilk 7'yi alacakken diyelim biz ikinci 7'nin pointer'ını istiyoruz. Onu
yes,
nasıl yapalım?
that is perfect. Those are very nice questions that you will be facing in your midterm exam. Note this somewhere. Those are generally the interview questions people ask in like Google, Amazon, those places, and they're highly likely to be a midterm question, which you should think about, right?
O get frequency off'la kullanabiliriz belki.
Maybe. A lot of ways. There are a lot of ways to do this, but I don't want to give spoiler here. It's really simple, but you should think a little bit. Like here, for example, when you find something, then you should also check the next items. If it's a sorted case, if it's unsorted, you should check whole items, right?
Anladım hocam.
So it's a very special, nice question, and it's highly likely to be an exam question. Okay. So I won't be implementing it here, but you should implement it. It's very simple. Just you should be very careful for different cases. Okay. So do you see any problems here? So we had this current is not null until we reach end, or an entry is not, if that entry is not equal to item, then we move and then we return that pointer. I think this should be done. Okay, what else we should implement? So we can implement something so that we can use it. Maybe contains function. So that will be very easy. So contains is, this only checks if we have that item in the list or not, right? So, and actually this get pointer to already makes this check. So
Hocam,
yes,
get pointer to eğer item yoksa null'u döndürecek mi? Yani null'sa zaten
because if we don't have the item, which means that this current will reach the end, which is going to be the null pointer, right? Is this clear? Right? Like we are moving current one by one. If we couldn't find the item, which means that it's going to fail here at some point. At some point, your current pointer will reach the last node and its next will be the null pointer. We will stop here and then we will return that current.
tamam.
Okay? Or we found it and we will return that pointer. So who was I talking with? I can't remember.
İpek.
Okay, Ipek, then I have a question for you. Don't disappear to somewhere, don't go. So I will implement the contains function based on get pointer to function. How can I do this?
Zaten we have an entry as an input,
Okay,
and get pointer gives the current location. We can use this with a Boolean statement. Return
okay. Parentheses. Okay.
An entry get pointer to.
I need to call the function name first. I need to write the function name first, get pointer to an entry, right? So now this will call the function and this function will return as a pointer. This will be either a pointer pointing to a node or it will be a null pointer.
We should check if it's not equal to null pointer.
Perfect. Thank you very much. Is this clear for everyone?
My pleasure.
Is this clear for everyone? So we just called get pointer to function and check if its output is equal to null. If it is, then this doesn't contain that item. This list doesn't contain that item. If it's not equal to null, which means that this list contains that item, right? That was very nice.
Hocam, sorum odakladı hocam.
Yes.
Hocam bu get pointer'da da biz eğer item yoksa bile en sona kadar gitmek zorunda kalıyoruz da.
Yes.
Şimdi current get item bu entry'den ne olduğu durumda büyük olduğu durumda zaten hani daha sonrasında yoktur. Çünkü shorted bir şey ya bu. Yani bizim entry'miz current get item'dan büyük olduğu durumda biz biliyoruz ki küçük olduğu durumda hani daha yoktur devamında.
Perfect. You will get a bonus from me for your quiz today. Just remind me after your quiz. So what Ahmed is trying to say is this is a sorted linked list, which means that if you already noticed an item which is larger than your entry, which is smaller than your entry, I think.
Right, sir.
Wait a second, larger than your entry, then the rest can't really have that item anymore because it's sorted. All the items also will be also larger than your entry. So what this will do is it will make our code more efficient because we won't be checking all the items. When we found something, then we are done. So we can just add one more condition here. So can I maybe modify this a little bit? So we will continue unless it's not equal to, is it small? Is this going to solve this problem?
But no, I think no, we need maybe another if, because if it is smaller than next item, it will be null pointer directly.
But I did not really understand.
If it is not in the array, we will return null pointer, right, sir?
Yes.
So when we
okay, I understand. I totally understand. So,
but maybe it not be a good code. Maybe it can't be a readable code. I don't know.
Yes. So we will need to make a lot of changes. Okay, I leave it for now. I will leave this as an inefficient code, but I want really everyone to understand this. Please practice this. So we need to make some changes here, but I don't want to spend time on this for now. But it's really something will be very easy, but it will make things much better. It will be more clear. So instead of traversing the entire list, if you reach an item which is larger than your target item, which means that you are done. You don't even need to check the rest. So please add that condition to this code. I guarantee you will face this somewhere, like in your exams, in your quizzes later. So please practice this. This is something very important.
Sir, maybe we can compare item count by a count variable. After that, we can, but again, we will return a null pointer.
Yes, exactly. It's really very easy. I can just add an if-else statement here. I just didn't want to change the code because it will take additional lines. But this is a practice question for all of you. Okay. Please.
Hocam bir de
efendim?
Burada mesela get frequency of'u kullansak öncesinde eğer varsa yapar. Ya yoksa hiç yapmaz diye öyle bir şey yapsak da olabilir mi?
You can. Just we are trying to make this as efficiently as we can.
Yani o da efficiency olur mu?
I am not sure. I really don't know. I need to compare those two things. But there are really many different ways to implement those things. But you should think about them and then you should decide, okay, like this will be more efficient, this will be This will stop earlier than the other code. So we will do those efficiencies as much as we can. But for now, I will just skip this. But this is a practice problem for everyone. This is something very important. And I think this will be the same issue also here in this get frequency of. So you don't even need to go until the end, because again, if you reach something larger, then you won't see that item again in the rest of the list. So you can add additional break statements in this code, like here as well. Also here you can add additional break statements, like stopping conditions for specific cases, and then you can make a return right there, right? Okay, let's continue. But this is a very important practice question you should be working on. This is something you will see face again in this class. Okay, so let's see what else we have. Did we finish? Yes, I think we finished this. We were implementing something, contains. Did we finish contains? Yes. Okay, so what else we have? We have two more functions, and then we will write the destructor, which is very easy. Let's implement the remove function, which is actually the most important thing here for now. Okay, let's go to remove function. Okay. So the idea in this, what happened? Does not match any. Okay, I need to open it also here. It couldn't match them. Okay, so the idea here is that we will now, whenever we get a new entry, we will remove that entry from our list. And then we have, again, if you remember our implementation, we had two specific conditions. If you're removing the first item, where we should update the head pointer, or if you're removing from an interim node or the last node, that will be a different case. So let's start. So let's try to implement this. I will try to explain this as much as I can, but please stop me if there is any issues that you want. So first of all, the first thing I will do is I will try to get a pointer to that entry. So node pointer, node to be removed will be, I will call get pointer to it an entry. So what happens here is that, so I know how get pointer to works. If that item is not in the list, that get pointer to will be null. So I will say, okay, full, I will return false, because I won't be able to remove that item, any item. Or if this pointer is not null, then I have an access to the pointer that I want to delete. Then I will delete it. But again, I need to make two checks. First of all, I need to check if it's the head pointer or null. So that is something very important, because if I'm deleting head pointer, it will be a different case, right? So just like we did in the array-based implementation, I will just say can remove item. So this is going to be a Boolean variable for it. So in which condition I can remove this item? So when this node pointer, node to be removed is not null, right? So if this node to be removed is not a null pointer, then I can remove the item. So this will be correct, right? So just like we did in arrays, I will say if I can remove that item, right? And then I will return can remove item. So it's like, if I cannot remove the item, I will directly skip to here, and then I will return false. If I can remove the item, I will do the content of this if statement, and then I will return my output. Is this clear for everyone? Is there any questions? Okay, so let's do our first check. So we have a pointer to the node that I want to clean, but I need to check if there is a head pointer, like if it's the first node, or if it's an interim node. So what I'm going to do is I will say if node to be removed is equal to head pointer. So that is a specific case that I need to be dealing with. Otherwise, I will be doing something else, right? Is this okay for everyone? So how do I implement if it's the head pointer? So it's like we have the head pointer, this is pointing to the first node. I will be just cleaning that node. So what I can do, I will just say, I will just move head pointer to the next node, right? Get next. So it's like, let's say I have this first node, head pointer is pointing to this node. What I did is I just moved head pointer to its next so that head pointer points now the rest of the list. And then I need to clean this node, this thing, but I will clean it anyway. So I will clean it, like, even if it's an if statement or else statement, I will be cleaning this thing. So I will be doing that cleaning operation right here. Is someone writing from chat? Okay. Sorry. So now I will be doing the cleaning operation here. I just adjusted pointers here. And then, so this is my first statement, first conditional check, where I'm only checking against if there is a head pointer or not. If it's head pointer, it's very easy. If it's not a head pointer, then what happens is I have a pointer somewhere, like pointer in the list, in your list. It's pointing some item, either an interim item or the last item. We don't know, but it doesn't matter. So that is pointing to that node. So what I should do now? So do you remember how we implemented the remove function?
We need previous pointer.
Perfect. We need a previous pointer. So we need to create another pointer here. And I don't know who was her again. Can you also say your name whenever you talk?
Ipek.
Ipek. Okay. Ipek is getting a lot of bonuses today. So let's say we have this previous pointer, right? So what I need to do is, so by definition, this should be the pointer right before that current pointer, which I am trying to remove. So for now, that current pointer is not to be removed. Who was it?
Teacher, why do we need another pointer? We can be removed, get item equal to data, and another then not to be removed, assign it to not to be removed next.
I really can't understand. Can you try to elaborate on this? I didn't really understand.
We should, if not to be removed get item equals to entry, then if that's true, then not to be removed equals to not to be removed next. So we don't need another pointer, I think.
But let's say we have 3 nodes. Let's say we have 4 nodes, and the one you want to delete is the 3rd node. So node to be removed is pointing to the 3rd node, right? If I take that node out, how do I make the connection between the initial part of the list to the last part of the list? Do you understand the issue?
We can we delete an item, so next item will be assigned to not to be removed, I think. Okay, you implement, and I'm going to ask again.
Okay. It's both are okay. Okay, so but my plan is to create another pointer called previous. So we will first find its location because it's uninitialized. So we need to make sure that the previous points to node right before the node to be removed. So what I'm going to do is I will initialize this with head pointer, and I will traverse the list and so that I can move it to the appropriate location. So what I will do is I will say previous arrow get next, oops, not item, get next is not equal to node to be removed. Just move previous. Move previous equals previous get next. So the whole purpose of this operation is create another pointer called previous and move it to the node right before the node to be removed, because I'm checking against if unless this will continue, unless the next of this previous is not to be removed, right? It will go all the way. This is one of the issues when you are working with linked list versus arrays. If it was array, if the index I'm trying to clean is 6, I can just directly access the 5th location. But in a linked list, this is not possible. We need to again start from the head, move all the way until we reach that item, right? So this is now previous. So now I have a pointer node to be removed pointing to the node that I want to clean, and then I have a pointer called previous. Now I need to make a pointer adjustment. So I will just say previous is set next. So I will connect next of previous to next of node to be removed. So I'm just taking node to be removed out from that list.
Hocam aradığımız sayı listede de olmayabilir. O yüzden while'ı end deyip sonuna kadar gitmesini de ekleyemez miyiz?
No, because if we came to this point, this guarantees that the number I'm looking for is in this list. If it wasn't in the list, I wouldn't even come to this point because I have safety checks before for that condition. Right? So I am first checking if that item is in the list. If it's not in the list, I don't even go here. Is this clear?
Anladım hocam.
Right? So the first thing I do is if that item is in the list or not. If it's not in the list, I don't do any of these. So if I'm going into these lines, which means that that item is in the list and I need to clean. Okay, so now I made all the pointer adjustments. Now I need to clean this node to be removed node. Like I need to delete that node. So in order to safely delete it, I will first I will set its next to null pointer so that it doesn't point anywhere in the list. And then I will delete that node to be removed. And then I can just make that node to be removed to null as null pointer. And then we need to make one more thing, of course. We need to reduce the item count, I think, right? Okay, so let's look at this again very fast. Okay, I hope everyone can see this. This is the remove function we implemented. So we first found the pointer, obtained the pointer to the node that we want to clean. And then we created a Boolean variable to check if it's in the list or not, if it's null or not. If it's in the list, then the thing I check is if it's the head pointer or not. If it's head pointer, it's very easy. If it's not, then I create a previous pointer, move it right before the node to be removed. And then I make again this pointer adjustments. When we are done, then we just clean that node and return it back to the memory, and we reduce the item count. Is this clear for everyone? This is very important.
Hocam,
yes.
Peki mesela bu kodda diyelim ki 2 tane olan bir sayının ilkini seçecek. Bu yeterli mi bizim için?
It depends. Like this is an operation contract. Now we are only saying that we will be removing only one occurrence of this entry. If you change this definition, so we can write another remove function. It's a remove, I think I'm using some Turkish words without knowing. So for instance, we can say remove all occurrences. We can create another function which will not only remove the first occurrence, it will remove all copies of it. You are perfectly right, but it's an operation contract. Now, the function we are implementing will just remove one of them. Basically, the first occurrence.
Okay.
Mm-hmm. Any other question? Are these codes all clear for everyone? Because let's do some tests. I won't really implement the clear function. That will be a homework for you. So the idea of this clear function is to start from the first node and remove them one by one. So you can even make a loop and call remove function for all those items. Like you can check the first item and call remove function. Check the second item, call remove function in a loop, and you can clear it. If you want, you don't even need to call the clear function. You can simply implement this. So I won't do that because we are running out of time, but let's test this remove function. So that is something very important. So here we added 5, we added 8, 7, 2. Let's remove 2 here. It doesn't matter where do you remove it. So let's remove, we don't need this frequency of anymore. So let's say, which one do you want to remove? Everyone. Any numbers that you want to remove? So up to now we have 2, 5, 7, 7, and 8. So what should we remove?
So,
What?
7.
7. So that should remove one of the 7s. So let's copy these. And then we need to check those special cases. So we need to remove something from the head. We need to remove something as like an interim node, which is now we are testing it. And then we need to remove the last node so that we check all those special conditions. Okay, so here the number of items is 5, 2, 5, 7, 7, 8, and then it says the number of items is 4 because it removed one of those 7s. So this works perfectly fine. And then let's do this one more time. And then this time I will be removing the first item, which is 2, just to see if I can successfully remove the first item. Perfect. It says 5, 7, 8. And then I will just remove the last item just to test that condition as well. And then let's finish the list. So let's say these are all working perfectly fine. I will just say remove 7, remove 5. So it should be 0 and print nothing. Perfect. So this remove function also works perfectly fine. Any questions?
Bir de mesela hocam olmayan bir sayıyı çıkartmak istediğimizde yine aynı link listi verecek değil mi?
Perfect. It should, but let's test. Maybe we can test this here. So we can try to remove 20, right? So we should repeat this before saying this number of 0. Yes, so it repeats the same thing before saying number of items is 0, right? Yeah, you should test all those special cases to make sure that your code is running perfectly fine. So normally when you write longer codes, there are some test protocols. So you just run that driver function so that it tests all those conditions and compares the expected results versus the obtained results, and then it gives you a performance. Like it says, okay, this is predicting 100%, or it says like this function, this special conditions fail. You need to check. This is how auto graders work in your softwares. Any other questions? Any other question?
Can I take performance question again in the get pointer function?
I didn't understand.
Our friend asked performance question. Get pointer. In
Okay.
get pointer. Can I get it again?
I really don't understand.
What was the question?
The last question?
Yes, you liked question. Performance question there was in get pointer method.
I don't really remember. Let me see. I think I forgot what I was talking about. Get pointer to this one. Oh, okay. You can see my screen. Wait a second. You mean the question about this get pointer to? Murat?
Yes, what was the problem in this question?
The issue is about efficiency here. I think
Yes,
you know this, if I didn't misunderstand. Like, if you find, oh, okay, you mean Ahmed's suggestion. Okay, so Ahmed was trying to say, like, you don't need to really check all the items until the end. This is a sorted linked list. So if you notice that the item in your current node is larger than your entry, you don't need to check the rest, because all of those items in the rest will be larger than your entry by definition of a sorted linked list. So you don't need to check the entire list. You can just stop whenever you see something larger than this entry, which means that you couldn't find it.
Okay.
And this is very nice.
If our entry is not in the list, that would be, for example,
Yes,
we don't
exactly,
10.
Exactly. If your entry is smaller than all the numbers in the list, and if it's not in the list, you can immediately stop without even checking anything. Like, you can check first
Okay.
item done, right?
Okay.
Okay, so we will be doing a quiz now, but I will be giving a like, let's say 4-minute break so that you have more time for your quiz, like 4 or 5-minute break. We can start in 11:26. Okay, in 5 minutes. You can come back and then we will be making a quiz. Okay, I will be here in 4 minutes.
Hocam kapatacak mısınız kayıtı?
Yes.
Durduracak mısınız?
I can actually stop it now.